Hello guys and welcome to class.
Done.
Teacher Krishna here, and we are working on the science subject as well as in class number 2. Let's start with our presentation and let me show you our topic and end in mind for today. Our topic is 1.03 Theories and Laws. And you have end in mind right over there. Differentiates between scientific theories and laws so that he or she can identify theories and laws specific to Earth space science and recognize how models explain theories and laws in science. Alright, might seem a little bit complicated and like a tongue twister, but don't worry. It's going to be a pretty simple topic. And here you have a summary of the activities that you need to complete. So, I need you to read topic 1.03 and state the main differences between theories and laws. That is going to be in your notebook, please. Then, complete the assessment 1.03. Once you are done with that, you need to conduct an investigation about real example between theories and laws to share the information with the class during the live session. So, we are going to have a couple of minutes during the live session in order to complete this activity, but of course, it's better if you can start working on that right now. And make sure you finish your investigation before the class. That will help you out not to have a lot of homework, otherwise you'll end up like this guy right here. Alright, so let's just jump into our topic. And first we're going to start by comparing legislative laws versus scientific laws. So legislative laws are created by humans. So some of our laws are found in our constitution, for example. There are things that you are not allowed to do inside our country because they are prohibited, right? And of course, they are created in order to keep peace in a more organized location or place. For example, one of our laws is that you cannot kill someone. If you kill someone, then you are going to go to jail. There are many other things that you cannot do, but those are laws that are created by humans. On the other hand, scientific laws are discovered in nature. They are universally applied. So, let's say that scientific laws are already there. They are everywhere around us. But what happens is that we start discovering them with time. So, for example, there you have a picture on the left. And it is a picture that is representing the discovery of gravity by it wasn't Albert Einstein, sorry. It was Isaac Newton. So Isaac Newton once was sitting down under a tree, an apple tree, and then an apple actually went down, or most likely fell off the tree, and then it hit his head. And he was like, hey, why does this happen? And that's how he discovered the law of gravity. So, scientific laws are already there in nature. And we are the ones that discover them. We don't have to create them. They are just there to be discovered. So let's continue. And now we're going to talk about a little bit more regarding the scientific laws. For that, I have the question, what is the speed of light? And probably this is going to blow your mind. Light travels at 300,000 kilometers per second. That's astonishing, right? Every single second, light is traveling 300,000 kilometers. That's amazing. And that's a scientific law. It's something that has been studied, and also it's something that has been proved, right? So it's something that cannot be changed. It's not like we can modify the speed of light. And what's also interesting is that after this law, there come a lot of theories, like a lot of hypotheses or things that people are just trying to figure out. And people say that if you travel faster than light, then you can travel in time. Just imagine that. Why is that? The thing is that our perception of time comes along with our perception of light. So if you can travel faster than what light can travel, then somehow you are going to be traveling in time. It's a little bit more complicated, but of course, right now we humans are not able to travel faster than time, travel faster than light, I mean. It only seems like science fiction, but who knows? Probably someday in the future we might be able to travel faster than light itself. Alright, we continue with scientific theories. They are ideas that have facts behind to support their credibility. So, an example of a theory is like Albert Einstein's theory of relativity, which explains that gravity curves space around it. That's why spaceships can orbit around Earth. It takes time to prove and disprove a theory, sometimes even years. So Albert Einstein was like a mastermind, and some people actually consider him like the smartest person on Earth. And one of his theories tries to explain like the picture that you see right there on the right. So usually we think that space is like plane, let's say, but in reality it is not like that, because it has different shapes. But Albert Einstein said that gravity is going to change is going to change the space around it, and it is going to cause it to curve. So just like you can see right here, like the space that is around Earth is changed due to the gravity that it is projecting towards it. So probably later on we're going to study a little bit more about this theory because it's astonishing as well. But that is just a theory. Because, I mean, it has evidence in everything, but it's not something that we have fully observed, let's say. It has evidence, of course, it has evidence, but it is not a law. It is just trying to explain something. And we are always going to have competing theories in the scientific world. In occasions, several theories are developed to try to explain the same phenomena, but only the one with the most evidence will be accepted. An example of that is Alfred Wegener, when he suggested that once all the continents were together, but due to the movement of plate tectonics, they separated. And when the theory was released, it was not accepted until technology studied the seafloor and found ridges and undersea volcanoes that supported this theory. So Alfred Wegener was another mastermind of history. And once he was analyzing a world map, and he noticed that the continents seemed to match together. For example, the coast from Africa seemed to match with the ones from South America. And so on and so forth. There were other interesting lines that were drawn in each one of the continents that seemed to match and bond together. So that's why he developed that theory. The problem was that we didn't have the technology back then to prove that his theory was right. But with the pass of time, we gathered more evidence. And of course, better technology was developed. And at the end, people actually had enough evidence to say that Alfred Wegener's theory was right. And a little joke around here, these are the people when they heard Wegener's theory for the first time. Yeah, pretty much they couldn't believe him, right? Because they didn't have evidence. They were like, oh, this guy's crazy. He's just invented that. But he got something right there. Now we continue with laws. So they describe the observable in nature, but it does not attempt to explain why. It only describes what you can see. For example, like the law of gravity, you only describe that the things come down to the ground because they are being pushed by almost like they are being pulled by a force. A scientific law is generated when several scientists come to a consensus about an observation, usually in the form of a mathematical equation. So, mathematics always goes along with science, because let's suppose that someone proposes a theory, but once it is mathematized, then other scientists can actually prove it and recreate the examples in their laboratories in several parts of the world. And at the end, if they get exactly the same results, and there is no way out of the mathematical equation, it means it's a law, and it's something that is true. Some examples are the Kepler's law of planetary motion. And basically they describe the motion of planets around like a star. Also we have that laws don't change into theories, and theories don't change into laws. That's very, very important. And again, Laws only describe what is observable in nature. Then theories try to explain why that happens. Alright, so that's pretty much it for today. I'll see you in the live session in a couple of minutes so we can keep on discussing a little bit more about it. Goodbye, guys.
Bye, have a great time.